Okay, so last time we talked about bad sampling, convenient samples, voluntary response samples. So today we're going to look more at good sampling. So we're going to start with random sampling, which would be what it would be considered ideal. Okay, so a random sample is any kind of chance process. That could be what we call the hat method, where you take everybody's, let's say we were trying to get a random sample of students from the school. We take everybody's name, put it in the hat, okay, and we pull out people randomly from the hat. Okay, so the hat method would work for a random sampling using your calculator. Okay, so you can use technology, and we'll look at how to do that in a little bit. But we could use our tech, and we could use our calculator and our random number generator to go ahead and generate a random number sample, a random sample. We can also use what we call Table D, and we'll look at an example of how to use Table D as well. Okay, what is key here, though, with no matter what method you choose, okay, is that it is a chance method. Okay, that is what makes it a random sample. As long as there is a chance method, it's due to chance. Okay, and a lot of times we use what we call a simple random sample. And a simple random sample is abbreviated here with our SRS. Okay, and so we get a sample size N. Okay, so N, you'll see N when we get into our formula charts more. Okay, N represents the sample size. So we get a sample size of N, 15 people, 100 people, whatever it is that we're looking for, in such a way that every group of individuals in the population has an equal chance to be selected as the sample. All the slips, if we are doing the hat method and we're putting everybody's name into the hat, all the slips are the exact same size, okay? And nobody has their name in there 3 or 4 times. Everybody has the exact same chance of being selected, okay? And that becomes what we call a simple random sample. So if you're choosing to do a simple random sample using technology, the first step that you're going to need to do is you're going to need to give every individual in the population a numerical value. And when you're giving them a numerical value, let's say we're trying to take a sample of 50 students from our school. When we're assigning, I think we started with 2,055 students. So when we're assigning those students numbers from 1 to 2,055, for certain kinds of methods, it will be important that you are keeping the number of places the same. So you would be assigning students numbers that look like this. That'll become more important when we do the Table D one in a little bit. So when we're doing an SRS with technology, you could do it on the computer. You go to like a randomizer website on a computer. You can do it on your calculator, which will be our most common form of technology, since that's what you're allowed to use on your test. Okay, so you're giving everybody a distinct numerical label from 1 to N. N is N is the size. You'll notice this N. Okay, so here you'll notice we have a capital N, where before it was a lowercase n, which equals our sample size. Okay, so here the capital N, that is your population size. Okay, so for example, if I'm trying to find a random sample of 50 students from opening day at West Mesquite, when we had 2,055 students enrolled, I would give everybody a number from 1 to 2,055. And then when I'm doing my random number generator on my calculator, I would tell it that I want an N, a sample size of 50, where this is my population size. Again, like I said before, notation is extremely important here. Okay, so you are going to need to get a handle on this notation. So our capital N is our population size and lowercase n is our sample size. Remember, your sample should be representative of your population. Okay, so once you've labeled everything, then the next step would be to use the random number generator to generate however many samples you want, whatever sample size you want from the population size. Okay, and we'll go over in class how to do it on your calculator, where everybody has their calculator in front of them, and we can run through it real quick on how to do it on the calculator. One of the things you will want to keep in mind when you are doing a random number generator and you're writing about it, because you're going to do a significant amount of writing as we go through the course, Okay? When you're writing about it, you need to specifically, you need to explicitly state that repeated integers are going to be ignored. You can't choose, for instance, again, if you're getting this sample size of 50 and you choose student number 10 and then they show up again in your list of randomly generated numbers, that won't work. Okay, so you have to state that your repeated integers will be ignored. Okay, and so just kind of keep that in mind when you're doing writing about this, that statement has to be made. Another option you have is what's called using Table D. So when you're doing an SRS using Table D, same as before, the first thing, if you're using technology, the first thing you need to do is you need to go through and number it. And this is going to be important where every digit, when you're numbering your population, that you're using the same number of digits. So 0, 1, 0, 2. Let's say you're going to let's say you had a population size of 100. Well, you'd be going 0, 0, 1 through 100 because you need every number to have the same number of digits in it. Okay, and then your next step then is to randomize. So it gives you directions here as to how to do that on this table. So you choose which line you're going to start at. Sometimes the problem will tell you could randomly choose it. You could put it in your number generator of your calculator and you're going to start on line 106, or you're going to start on line 225. Okay, so you read consecutive groups of digits of the appropriate length from left to right across the line in Table D. You ignore any group, so we're back again, ignore any group of digits that wasn't used as a label or that duplicates. Okay, so you get rid of your duplicates, okay, that are already in the sample. Stop when you have chosen however many it is that you want. So let's say we wanted a sample size. So this is our population, 100, okay, and we want to find a sample size. We want to take a sample size of 5. Okay, so we've numbered everything 0, 1 through 100. And let's say I'm going to start here on line 101, just because to make sure that we have enough information going on here. So we're going to start here on line 101. Okay, so we start there. And basically, I'm going to run down this line to my right, and I'm going to be looking at the clumps of 3. So I'm going to look right here. Oh, it's hard to do with my finger. Okay, so 192 to, that's a clump of 3. Okay, well, 192 is bigger than my population size, so that doesn't work. 239, okay, that's a clump of 3, that's still bigger. And then I've got 503, still bigger. 405, still can't use these numbers. 756, 287, 139, 640, 912. This example might not work at all. 531, 425, 448, 285. Okay. So I would go through until I found something that fit my particular numbers. Let's see if we can find it on line 102. 736, 764. All these are too big, so I have to ignore those. 715, 099. There's my first one. Okay, so that's my first one in my sample. 400, that's too big. 019. Okay, there I got a second number in my sample. 272, 775, 442, 648. Hopefully you guys are getting the idea here. 824, 253, 629. Okay, and so we would keep going until we got 5 numbers because we wanted a sample size of 5. Let's say I'm going through and I got 019 again. Okay, well I have to ignore that. I go to the next one that I get. Okay, I can't have any duplicates in this list either. So that's how you're going to go through and you're going to use your Table D. If it was clumps of 4 numbers, then you'd go 4. If it was 1 or 2, you would, however many, whatever size the numbers are. So let's look at an example of this. Okay, let me go through and erase this stuff. Okay, so let's look at this example here. I don't know why that's moving. I want this to move right here. Okay, so... All right, the school newspaper is planning an article on family-friendly, places to stay over spring break at a nearby beach town. The editors intend to call 4 randomly chosen hotels to ask about their amenities for families with children. They have an alphabetized list of all 28 hotels in the town. Okay, so you're usually supposed to use table D at line 130 to choose an SRS of 4 hotels for the editors to call. Okay, well, let's think about this for a little bit here. Our population here, right? Our population size here is 28. So that means all the hotels need to be numbered 01 through 28. My sample size here is 4. Okay, so this time instead of going in clumps of 3, I'd be going in clumps of 2 digits. Okay, I'm using table D at line 30. So it tells me to start at line 30. Okay, you can see the list of hotels on page 217 in your book. They're just alphabetized, so the hotels were alphabetized, and then they were all assigned a number. Okay, I went ahead and clipped step 2 of the solving, okay, so that you could see that here. Otherwise, we would run out of room on your page. Okay, so the randomizing part, right? We're starting at line 130. They gave us, this is line 130 right here. Okay, so in my clumps, right, I get 69. I get 05. Okay, well, 05 fits. It's between 01 to 28. Okay, and then I get 16. So that fits our criteria. 48 is too big. 17 is good. 87 is too big. 17 I have to skip because it's a repeat. I can't do it again. Okay, 40 is too big. 95 is too big. Okay, I got 17 again, which is a repeat. Okay, so I can't use any of those. Okay, 84 is too big. 53 is too big. 40 is too big. 64, 89, 87, 20. Okay, so I could use 20. Then I get 19. Okay, and that is 4. So those will be the 4 hotels that we would call based on this method of randomly selecting a sample from this population. So we would call hotels that correspond to numbers 5, 16, 20, and 19. Correct, and we wouldn't even need number 19. I left out number 17 there. So our sample would consist of the hotels 5, 16, 17, and 20. Those are the 4 hotels we would call. So instead of a simple random sample, you may want to kind of group individuals in a certain manner before you start taking your sample. And one of those ways may be with what we call a stratified random sample. So for a stratified random sample, you're going to divide or classify the population into groups called strata. Okay, and so you're going to stratify the population. And so when you're doing that, the strata, you're going to have groups of similar individuals within the population. So each strata is going to have something in common. Again, going back to our high school example, the strata could be 9th grade, 10th grade, 11th grade, 12th grade. Okay, and so you're going to divide the population into these strata, and then within the strata, you will do an SRS within that particular stratum. And so let's say, again, we're talking about the high school, we would do a simple random sample and SRS on 9th graders, 10th graders, 11th graders, and 12th graders, and then we would combine all of that to form the sample. Okay? You can also cluster. Okay? And when you cluster, that's based solely on location. Okay? So when you're dividing for a stratified sample, you've got a particular like trait or characteristic or something that they have in common that you're dividing them by. If you're doing a cluster sample, it's all about just location. Are they located near one another? So, for example, again with the high school, we could do cluster samples of a science classroom, a math classroom, an English classroom, and a social studies classroom. And when you do a cluster sample like that, you're sampling from all of the individuals in the cluster. So you would take like I said, you would take a math class and you'd sample every kid in there, 9th, 10th, 11th, 12th grade, whatever. You could take a PE class, you could take a band class, you could take a science class, and so you would be sampling every individual that's in the math class, in the P class, in the band class, in the science class, okay? And then those are all included into our sample. So again, you can do the strata, which is putting everybody together based on something they have in common, or you can do the cluster, where you take your SRSs of clusters, which are all solely based on locations. Okay, so let's look at an example of this. Let me get rid of some of this stuff here. Okay, so let's look at this example here. So the student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium about the use of the school library. They would like to announce the results of the survey at the end of the assembly. The student council president asks your statistics class to help carry out the survey. Okay, so your problem is here, you have 800 students present at the assembly. So in theory, this should be, that 800 should be your population, because it said it was an all-school assembly. Okay, a map of the auditorium is given to you here. So here's a map of the auditorium. Okay, y'all will be constructing your own maps of things to be able to do sampling for a project later. Okay, so here's a map of the auditorium, and note that the students are seated by grade level and that the seats are numbered from 1 to 800. Okay, so how would be, how are we going to sample this? What would be the best way to sample this? So you have ninth graders, which are sitting in seats 601 to 800. Okay, and then you have 10th graders in 401 through 600. 11th graders in 201 through 400, and 12th graders in 1 through 200. Okay, so our problem here is to describe how we would use our calculator to select 80 students to complete the survey with each of the following. So if we're doing this with a simple random sample, so let's start with A there. We're going to try to do a complete SRS. So if I want an SRS of this entire assembly, well, remember there's 2 steps to everything. First of all, I need to number everything. Well, everything is numbered for us because we're in seat numbers. Okay, so I did step 1, which is to label everything or give everything a number. And step 2 would be to randomize it. So we would use the function on our calculator. Again, I'll show you where this is located and stuff on your calculator. 1 through 800, because that's my population size. Okay, and I need to go until I get 80 different seats. Remember, I cannot have repeats. I need to state that I'm going to ignore my repeats. Okay, this is terrible stating. I will not always write incomplete sentences on the screen, basically for legibility purposes, so you can read it, and because of what fits on the screen. In class, we will practice significantly with exactly what to say and how to say it. Okay, and so out of those, once we get 80 randomly generated seats that are, we don't have any repeats, we give the survey to all of them. So that's how we would do our SRS for this. If I want to stratify, if I want to get a stratified random sample, okay, so we're looking at B here now, the stratified random sample. Well, my stratified random sample, they're already stratified for me, right? It's already done by grade level, and we know where each grade level is sitting. Okay, so we need a total sample size of 80, and there are 4 grade levels. So we can take an SRS of, like, for instance, of the 9th graders. So for seats 601 through 800, I can get a sample of 20 for them. I can do the same thing then for the 10th graders. So seats 401 through 600, and again get a sample of 20 from them. And the same for the juniors and the same for the seniors. Okay, and so then I'm giving the survey to 80 students. Okay, and I did 20 from each of the different strata. Okay, as for the last one, where I'm going to do a cluster sample now. So for part C, I've got a cluster sample. Okay, and so if you look at the map here, okay, we could kind of use the map and the rows, the columns here, okay, to try to come up with some good clusters. So to do that, we do not want to use the rows that are going like side to side, because those would be, you'd only be sampling freshmen or you'd only be sampling seniors. Okay, we would need to use the columns that go back like that. Okay, seat 11, 21, 31, 41, 51, 61, okay, all the way up through. Okay, if you follow the column all the way back, you get 40 seats. So I have 1 through 20 here, right? I have 1 through 20. So this time in my calculator, I could put in 1 through 20, and I need 2 columns from those. I need 2 numbers from those because each one would give me 40 seats, and so then I would end up with my I'd sample from 2 of these columns, let's say column 11 and column 6. I'd get my sample of 80. It should be representative of the population because it should include seniors, juniors, sophomores, and freshmen. Okay, but that would be how we would cluster sample that. Okay, we're going to look at a few more examples of these. Again, I will say the complete answer, but I will not write it all out. It will be difficult for you to read it if I did. Okay, but again, I will say the complete answer, and you have the problem in front of you in your notes. So feel free to get it down so that you have a good quality explanation of what the answer is and how you are expected to write. Okay, pause it for a second and figure out exactly what the problem is asking you. Okay, so go ahead and pause it and read the problem. So hopefully you read it, okay, and you understand what the question is asking you. So let's look at the first one. Question 1 there says, explain why it might be difficult to give the survey to an SRS of 200 fans. Okay, if I'm doing an SRS of 200 fans, I need to end up identifying. Sorry, I thought I had the pencil on. I need to end up identifying 200 seats in this arena. Okay, well remember this arena has 20,000 fans that are in attendance. So to do an SRS there, I am basically numbering every seat 1 through 20,000, and I'm IDing 200 of those seats. And then I need to run around the entire arena and find those people. They're not all going to be in the same section. Some will be at the top, some will be at the bottom. Okay, yes, it will give me a random sample from all over the place, but that actually is kind of the problem, that it's a sample from all over the place. So you'd have to be visiting all these individual 200 fans no matter where they are in the arena, which could be difficult. Okay, so the next one then is asking which would be a better way to take a stratified random sample of fans using the lettered rows or the numbered sections as strata. Let's go back and see what it says as regarding the setup of the arena. Okay, it says that the arena is divided into 30 numbered sections from 101 to 130. Each section has rows of seats labeled from A to, which is down by the court, to ZZ, which is the top up by the arena. So remember, in the strata, when we create a strata, we are looking to create people within the stratum that are very similar to each other, but different from the people in the other strata. Remember, we want these different separate groups. So in this case, it would be better to take the lettered rows as your strata, and then you basically would have all people. So if you can kind of envision what they're talking about with this arena here, right? Here's your basketball court down here, and people are sitting around it, right? And you have section, 101. So like I said, this is section 101. We have people down here in row A and people way up here in row ZZ. Okay, and that continues all the way around, right? This is still A. Sorry for those of you that were totally able to visualize the arena. Okay, so you get it. That's A all the way around. Like here's section 102. So it would make more sense for this right here to be a strata. These are all people that have something in common. How much they paid for their seat, how much they're willing to pay for their seat, how much they can afford to pay for their seat. And then each of the lettered rows would be a strata. The people up here in ZZ being their own stratum, they have a different, maybe they might have different interest in the game. They might have a different, they have different amount of money to spend on the game. So the best way to form the strata for this particular sample would be in the letter rows. Okay, the third part there, where it asks which would be a better way to take a cluster sample. Well, a cluster sample would be better coming from the numbered sections. Okay, so for example, 101 would be a better cluster because that cluster then is able to reflect the variability in the population. It reflects the people down here that are paying a lot of money for their ticket, as well as the people up top that are not paying as much money for their ticket. So it should be representative of the population as a whole, okay, because it has this variety in it. And then you could just sample everybody in this one section as your sample. Okay? Whereas if you did the strata, you'd be getting an SRS from row A, an SRS from row B, an SRS from row ZZ. But that would be the best way to cluster it, would be by the numbered sections. So based on this random sampling, you can now hopefully draw some inferences. Okay? And so when you're drawing inferences, you're drawing conclusions about the population based off of the sample that you gathered. Okay? And how can you trust that? Like, how can you trust random sampling is going to give you a pretty accurate description of your population? Okay? Well, what you'll see is that our results aren't going to change haphazardly from sample to sample. Okay? They're going to kind of stay in the same range. That's why when you graph these things, if you took bunches and bunches of samples, a lot of times you're going to end up seeing your normal distribution or your bell curve. Okay? Because the samples aren't changing all over the place. Okay, they obey the laws of probability. Okay, the laws of probability govern chance behavior. We'll talk more about probability and what that means as it gets closer to Christmas. Okay, they do give you good data to be able to make some trustworthy inferences of your population. And one of the things that we need to keep in mind is that the greater the sample size, the better the information is. And just kind of think about that logically, right? The more samples that we take, the more accurate description we're going to get of the population. Okay, so the last thing we're going to look at is kind of what can go wrong with a sample survey. Okay, in addition to the bad methods to sampling. Okay, so we had the bad methods that we talked about before, convenience or voluntary response, and that giving us bias. Okay, and some other things that could also lead to bias or be a result of bias. We can have what we call undercoverage. Okay, so undercoverage is when you've got some members of the population that cannot be chosen for the sample. Okay, for instance, let's say that we're, asking something about school and we're sampling from first period. So we could be suffering from undercoverage because of anyone that has first period on another campus, somebody that has late arrival. Those people cannot be chosen in the sample. They're not physically on campus to be part of the sample, so they could not be chosen for the sample. So we could lead to some undercoverage, kind of depending upon what the question was. Okay. One of the other things that could be a problem is what we call non-response. Okay. Non-response is exactly what it sounds like. Okay. You've chosen an individual to be part of the sample, and they can't or won't participate. Okay, this is going to happen a lot with like a phone poll. Back a long time ago when we had landlines, people would call the house to ask survey questions, that kind of thing. Okay, and if they got hung up on, okay, or ignored, or somebody looked at caller ID and didn't recognize the number, so you get this non-response. So you have undercoverage, where you've got members of the population that cannot be chosen, okay, and you have non-response, which is cannot or will not participate. So the two are different, but either way, you're not getting data when you should be getting data. You can also get what's called response bias. Okay, response bias This is basically you get a systematic pattern of inaccurate answers in a survey. You're getting this pattern that's happening. It could be due to gender. It could be due to race. It could be due to age, ethnicity, behavior, religious belief. Okay? But with this response bias, you're getting this systematic inaccurate answering of the question. Also leading to bias can be how the question is worded. Okay, and we'll look at some examples of that, but question wording can lead to bias. And so again, you're either overestimating or underestimating what the population thinks, okay, or believes, or whatever it is that you're asking about, okay, as well as the order of the question. You may be asking a series of questions, and the order that you ask of them makes a difference. For example, you could ask the question, how happy are you with your life in general? Okay, answer on a scale of 1 to 5, followed by how many dates did you have last month? But if you switch the order of that and you said, how many dates did you have last month? And maybe somebody had 0 dates last month, then they may answer the how happy are you with your life in general question a little bit differently than had that one been the first one. Okay, let's look at some ways of wording the question that could be make it a little bit biased. Okay, so let me get rid of, there we go. Like, let's look here. How do Americans feel about illegal immigration? Okay, should illegal immigrants be prosecuted and deported for being in the U.S. illegally, or shouldn't they? Ask this question in an opinion poll. 69% favored deportation. Okay, but when the very same sample was asked, so the exact same people are asked, okay, they're asked whether illegal immigrants who have worked in the United States for 2 years should be given a chance to keep their jobs and eventually apply for legal status. 62% said that they should. Different questions, but if you look at the question, they're about the same thing, right? The first question is saying that if you're an illegal immigrant, should you be deported or not? The second question is still talking about illegal immigrants, but has added in the fact that they have worked in the United States for 2 years. Now, 62% of the people say they should be given a chance to apply for legal status, where before 69% said they should be deported. Okay, so that is all about the wording of the question. We'll talk more about your response bias projects probably next class. Okay, but this is one way that you're going to be trying to create bias within your project. The wording of the question is one way that you really can make that happen, and you can see that happen. Okay, let's look at these last set of examples, and then we'll finally be all set. Okay, so looking here, number 1, each of the following is a possible source of bias in a sample survey. Name the type of bias that could result. So what we have going on here, okay, in the first one, the sample is chosen at random from a telephone directory. So what is our possible source of bias right here? Okay, well, we're most likely here to have undercoverage. And we're most likely here to have undercoverage because not everybody's listed in the telephone directory. They may not have a phone, especially at this stage in the game. They may not have a landline. They may not have a phone. Okay? Or they may choose to have an unlisted phone number that's not there. So there will be people that cannot be part of the sample because they either don't have a phone or they are unlisted in the telephone directory. So you get that undercoverage. They cannot be part of the sample. So question B then, some people cannot be contacted in 5 calls. Okay, that would be an example of non-response. It's not that they're not listed. It's not that they cannot be part of the sample. Okay, it's that they will not, okay, or they're unavailable, but we tried to include them in the sample. So this would be a non-response type of bias. Okay, so then we're looking at the last one here. Interviewers choose people walking by on the sidewalk to interview. Okay, well, I've got plenty of people that are not walking by me on the sidewalk. Okay, so they cannot be part of my sample. So I run that risk of undercoverage. All right, number 2, a survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here's the actual question. It is estimated that disposable diapers account for less than 2% of the trash in today's landfills. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? Okay. Explain how the wording of the question could result in bias. Be sure to specify the direction of the bias. So the way this question is worded, it makes it kind of sound like disposable diapers aren't really a big deal. They account for less than 2% of the trash in today's landfill. They listed all these other things, beverage containers, mail, yard waste for 21% of the trash. So they make it sound like disposable diapers aren't that big of a deal. So you're most likely here to have a large proportion say no, that it's no big deal, that we do not need to ban diapers. So we're likely, the way this question is worded, is to have a decrease in the amount of yeses that would suggest that we ban disposable diapers. But if you didn't have all of this kind of background information happening first, you could end up with a different number of people that might say yes. Okay, there's a lot, they could have front-loaded this question with information about how long it takes the diapers to decay, to break down in the landfill. It doesn't matter that there's less than 2% of them if they're sitting there for 50 years. Okay, so this one is most likely, the way this question is worded, would most likely underestimate the amount of people that would actually say yes to banning the diapers because of the wording of this particular question. Okay, and so you guys will have a chance to construct your own questions and kind of come up with ways that you can basically create bias when you guys get to your projects.